Hi everyone. In this video, we are going to learn one way of plotting these rational functions of a particular kind. We learn a more general method later on. However, this method sort of ties to what you've learned before, which is about graph transformations. Okay, so the goal is to use graph transformation to plot. So that's what I meant by specific kind of rational function, functions which are linear function divided by linear function. So we're going to restrict to that from the graph of 1 over x. So the goal is to use this graph of 1 over x, which we know what that looks like. Roughly speaking, that's what 1 over x looks like. And since we know transformations, we know we can move this left, right, up, down, stretch, shrink. So using some combination, some or all combinations of those transformations, our goal is to understand if we can express this function as a transformation of 1 over x. So here's how we're going to do it. I'm going to write this as 2 times 1 over x minus 3. Okay, which means that if we start with, say, px equals 1 over x, right? And then on this I make the transformation, or let's do it as a sequence of transformation. So I have 1 over x, right? If I replace x by x minus 3, I get 1 over x minus 3. And then if I do 2 times, right, f of x, 2 times p of x, sorry, then this becomes 2 times 1 over x minus 3. Which means we start with the graph of 1 over x. Changing x to x minus 3 is, we know what does that correspond to? That corresponds to move 3 units to the right. So if I move this graph 3 units to the right, what is going to happen? This asymptote at 0 is now going to be at 3. And then it's going to behave the same way, but there's going to be some point here where it crosses the 0, which is fine. And then lastly, we multiply by 2. Multiply by 2 just means we stretch. How do we stretch? Stretch vertically. Now if I stretch this image vertically, it's not going to change where my asymptote is, right? And if you're making a rough sketch, there's hardly going to be any difference in how it looks like, because the basic shape remains the same, right? That's the whole point of these transformations. So now, using just transformation and the fact that we know the graph of 1 over x, we have a graph of 2 over x minus 3, and we also know that this has a vertical asymptote at x equals 3, which you could have directly sort of obtained from the fact that you have an x minus 3 in the denominator, and so that it's 3 is not in the domain, so there's going to be an asymptote there. However, you don't have to do the analysis of what happens near 3, because you already know how 1 over x behaves, and that already tells you how 2 over x minus 3 is going to behave. Let's look at another example. Express as transformation of 1 over x again. Now this is not straightforward, but I can do some some algebra in here, and I can write this as 3x plus 6 minus 1 over x plus 2, right? Basically, I'm saying I'm rewriting 5 as 6 minus 1. There's a point to why I'm doing that. It's because now I can split this into 2 fractions, 3x plus 6 over x plus 2 minus 1 over x plus 2. And then you'll notice that if you factor the numerator of the first, this is 3 times x plus 2 over x plus 2 minus 1 over x plus 2, which cancels out, and you end up with 3 minus 1 over x plus 2. And now we are in the right position to do the transformations. The first one is x replaced by x plus 2. The second one is f of x becomes negative f of x. You multiply by negative 1. And the last one is, or if you are more comfortable with the y notation, this is basically y being replaced by negative y, and here y being replaced by y plus 3, so I'm adding 3 to the function. Now we know what each of these operations does. This is a left shift by 2. Replacing y by negative y. What does that mean? All of my outputs get switched. If my output is positive, it's now negative. It was negative, it's now positive. So this is reflect about x-axis. And then lastly, y equals y plus 3 means you are increasing all the output by 3. So you are shifting everything up. So this is an upshift by 3. Now that you have identified the transformation and the corresponding physical motion that they represent, we can start with a graph of 1 over x. Left shift this by 2. The left shift means the asymptote now is at x equals negative 2. So that's that. Reflect about the x-axis. So if I reflect about the x-axis, the asymptote doesn't change. All that changes is this negative part now becomes positive. So it's going to go over here. And the positive part now becomes negative, and all of that is going to go over here. So this is still x equals negative 2. And then lastly, upshift by 3. Again, that's not going to affect where the vertical asymptote is. I'm shifting everything up by 3, so that this point, if you notice, that is 0, is now going to be at 3. So this is going to be y equals 3, and this is going to be, it's going to intersect somewhere, and it's going to approach y equals 3. So this y shift changed the horizontal asymptote. The horizontal asymptote, which was at 0, is now gone up to 3. Right? That's because we are adding 3 to this function, which is always decreasing. So that gives me a picture of, well, this is y equals negative 2. So it tells me that there is a vertical asymptote at y equals negative 2 and a horizontal asymptote at x equals negative 2 for the first one and y equals 3 for the second one. Okay, so that's how that kind of works out. Okay, now we need to learn a general way of finding these asymptotes. We can always rely on this technique of expressing as a transformation of 1 over x. It is always going to work. However, for higher powers of polynomial, it can get cumbersome. Okay, so it's a great method for linear, but for more general functions, we want to generalize the process. So we will cover that in the next video. That's it for this video. Thank you.